Hey kids! Here in this section we're going to talk about, this is section 1.3 by the way, we're going to talk about midpoints, segment bisectors, and the distance formula and the midpoint formula. Alright, we're going to start out with midpoint. We have definition of midpoint. A midpoint, B for example, B is the midpoint of segment AC, if and only if AB is congruent to BC. So segment AB is congruent to, we've seen that symbol before, segment BC. And what is congruent to means is that the distance between A and B equals or is the same number, same as the distance from B to C. On a diagram, you will sometimes see these little tick marks here. These little tick marks mean that the distance from B to C is the same as the distance from A to B. It doesn't have to be two. It could be a single tick mark here and a single tick mark here, or maybe 3 tick marks here and 3 tick marks here. Usually it's 1, 2, or 3. But regardless, the same number of marks means they're the same length. Alright. Do 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 do. Okay, a couple other things about the bisector. A couple other things to think about here is that the midpoint. The midpoint B divides segment AC into two congruent or equal. I wrote equal, but then I scratched it out because I'm dividing it into congruent parts. But congruent, equal, pretty much mean the same thing. So if you say B is the midpoint, you're saying that it divides this segment into two congruent parts that are equal lengths. It also means that B is the halfway point between A and C. The halfway point. And it means that B is the same distance from A and C. So from B to C, B to A, same difference, same distance. And the other thing to think about is that anytime you know one of these things about a point, if you know that B is the halfway point, if you know B is the same distance from B or from the endpoints, you know that it's the midpoint because all of these things mean that it's the midpoint. Okay? All right, moving on. We now have the idea of a segment bisector. So definition of segment bisector by the word bi. Bi means two, as in bicycle, bifocals, or anything else that starts with bi. Two. So a bisector cuts into two, and in this case, two equal parts. Or a bisector is an object, and I notice I put this all in red here, and circle it. An object is a segment bisector of AB, segment AB, so it's a segment bisector if and only if an object, that same object, intersects with segment AB at its midpoint. An object can be nearly anything. So here, circle M, it cuts through segment AB at its midpoint. See the marks here, right? From C to B is the same as C to A. That means that C is right in the middle. It's the midpoint. It's on this circle. That makes circle M a segment bisector. Over here, you've got that this line here, line L, cuts through segment AB at point C, and C is the same distance from B, according to the tick marks, as it is from A, which means C is the midpoint, and therefore line L cuts through segment AB at the midpoint C, and it is a segment bisector. Also, ray CD, even though it doesn't really cut through, it does start here, it does touch, it intersects AB at point C. Point C is both on the segment and on the ray. And From C to B, 3 tick marks. From C to A, 3 tick marks. So C is the midpoint. The intersection of the ray CD and the segment AB is that midpoint, and therefore that ray is also a segment bisector. Finally, we've got an example here of a segment DE. It cuts through AB at point C. From C to B is the same distance as from C to A. Notice the tick marks, 1, 1. Therefore, segment DE is a segment bisector of AB. So, if at any point you're told that something is a segment bisector of a segment, then you know the place where that thing intersects or crosses the segment is the midpoint. So if I was told that, say, circle M was a segment bisector of AB, even without the tick marks, I would know C was the midpoint, because that's what it means to be a segment bisector. Moving on. Oftentimes a textbook maker or writer might toss you a little bit of algebra in with your geometry in order to keep your skills fresh. Here's a common way they do it. Here we have a segment VW and point M in the middle. Notice that from M to V, 2 tick marks. From M to W, 2 tick marks. That means that M is the midpoint. I know that VM is 4x minus 1. All right, we're told that. So that means whatever the length of VM is, remember VM is a number, it's a length. Whatever that length is, it's 4x minus 1. I just don't know what x is. If I knew what x was, I could do the math and figure out what the length was. I know over here that MW is 3x plus 3 over here. Again, if I knew what x was, I could figure out what this number, I would just plug it in and I would figure out what MW was. Is it 3? Is it 5? Is it 9? Who knows? Oh, we're going to find out. We're instructed to find the length of VM. Oh, wait, yeah, that's what we're trying to find here. How long is that? 4x plus minus 1 is VM. We're supposed to find what VM is. We need to figure out what x is. Well, here's our trick. We know that the distance from V to M and M to V, M to W is the same. So VM is equal to MW because M is a bisector or a midpoint. I know that VM is 4x minus 1 because I was told that up here. And I know that MW is 3x plus 3 because I was told that right up here. So I just have to solve this equation. Well, I'm going to take 3x from this side. And my purpose for doing that is because I want all of my x's on one side of the equation. So I don't want to have any over here because I want them all over here. So take 3x away here. Take 3x away on this side because that's the golden rule of equations. Whatever you do to one side, you have to do to the other. And 4x minus 3x is just a single x left over. So I end up with x minus 1. This negative 1 here wasn't changed. It carries down to the next line. And on this side, our 3x is now gone, but we still have this 3 over here. Next up, I want to get the x by itself, so I need to get rid of this negative 1. I do that by adding a 1. I'm going to add 1 to both sides, and that gives me x equals 4. So now I know x is 4, but remember I wasn't supposed to find x. I was supposed to find VM, the length of segment VM, right over here. Well, it's going to be very helpful to know that x is 4 because all I'm going to have to do is put a 4 in here. Let's take a look. Here, I knew that VM was 4x plus 1. I knew that x was, that's supposed to be a 4 there. X is 4. So 4 times 4 is 12. And then I add the 1, I get 13. And VM is 13 altogether. Heads up, this is a pretty common problem that they might toss you, but be careful what they're asking. Sometimes they might simply ask you to find x and you're done. Sometimes, on the other hand, they might ask you to take the extra step and find the segment length itself, like they did here. Make sure you know what you're doing before you finish it up. Next up, we're going to be taking a look at midpoints, finding midpoints in analytic geometry. Remember, analytic geometry is the kind of geometry that involves grids and coordinates and so on. Now, in the regular geometry, we knew that the midpoint was the same distance from B as it is from A, or whatever our endpoints are. The midpoint is, here's a word for you, equidistant from 1 to both endpoints. Same distance from the midpoint to the end as it is from the midpoint to the other end. So, oh, sorry, lost myself there. Anyways, that was all that our Euclidean geometry cared about, that these two distances were the same. We didn't care what they actually were. Well, now that we're in analytic geometry, we do care how far they actually are. And so we'd like to know where this location actually is on the grid. Well, the trick here, that midpoint is halfway between the 2 points up, down, and halfway between the 2 points left, right. So to look here, from -3, -2, -1, 0, 1, 2, 3, 4, 5. It is a total of 1, 2, 3, 4, 5, 6, 7, 8 spaces from -3 to +5, 8 spaces over. So that midpoint is going to be 1, 2, 3, 4 spaces over. So it's going to be somewhere on this line up, down. Then this A is at -2, that's its y coordinate, and B, the y coordinate is 3. So from -2, just kind of move over to make this easier. From -2, we have -1, 0, 1, 2, 3, or 1, 2, 3, 4, 5 spaces total. So halfway up would be 2.5. That's 1, 2.5. So the midpoint is somewhere on this line, which is vertically halfway between A and B. Well, the place where the two lines cross, where we're both halfway vertically and halfway horizontally, that point is 1, 1/2, or over a space, up a half a space. Now, you might not always have a grid in front of you, and your numbers might not always be nice whole numbers. Sometimes you might have fractions or decimals or weird irrational numbers, all sorts of strange stuff, and you have to find that midpoint. You can't just count spaces, how far over, how far up, and cut it in half. So it's nice to have a formula. And we're going to take a look at that formula next. The formula is right here. We're actually going to use that same example as we did before, right above. The points are the same. Formula goes like this. We find the x-coordinate and we find the y-coordinate of the midpoint. X-coordinate of the midpoint, y-coordinate of the midpoint. We find them separately. To find the x-coordinate of the midpoint, we take the x-coordinates of the endpoints, we add them together, and we divide them by 2. Now, I know this is x sub a and x sub b, but that just means the x-coordinate of point A and the x-coordinate of point B. It could be the x-coordinate of point J, L, K, M, R, it doesn't matter. Just the x-coordinate from one point and the x-coordinate from the other. You add them together, you divide by 2. It doesn't matter which point is which. And this x sub m, and we would say x sub m, that x sub m simply means the x-coordinate for the midpoint. X-coordinate for the midpoint. All right, over here for the y-coordinate, it's just the y-coordinate of A and the y-coordinate of B, or just the two y-coordinates of the endpoints, wherever they happen to be. You add them together, you divide by 2, and then that gives you the y-coordinate of the midpoint. So for a specific example, if you look back at our grid up here, remember our points were, we had -3, -2, and 5, 3. So our x-coordinates were -3 and 5. So we'll go down here. We have -3 and 5 for our x-coordinates. So we'll go up here and just look at our y-coordinates real quick. We've got -2 and 3. So I'll go back down to here. And we'll see that our y-coordinates are -2 and 3. So -3 plus 5, that works out to 2. And 2 divided by 2 is 1. So the x-coordinate for our midpoint is 1. Over here, -2 and 3 add up to get 1 divided by 2. And you could say 0.5, or you could just leave it as a fraction, 1 over 2. So the y-coordinate is 1 over 2. And if you look back at what we found originally, that halfway point is 1 over 2. So the same thing that we found by kind of drawing a picture and counting spaces is also what we got by doing the calculations with this formula. So formula seems to be in pretty good shape. Next up, we got to deal with using the mid formula to find endpoints. So in the previous example, we used the midpoint formula to find a midpoint. That was pretty convenient because the x-coordinate of the midpoint, we had a nice formula for it here. The y-coordinate for the midpoint, we had a nice formula for it here. And then we just kind of plugged them together and we were done. Well, it's a little bit more complicated if you want to find an endpoint, but you pretty much use the same formula. So here we have point T and point U. Point U is missing its coordinates, but they're in here, trust me. Oh wait, we don't know them. Point T, point U, we're trying to find the coordinates for point U. And here's our midpoint, 2. Now think about this. The x-coordinate, 2, is halfway between 1 and 3. And 4 is halfway between 1 and, let's see, 1, 2, 3, 4, 5, 6, 7. So our y-coordinate will be 7 and our x-coordinate will be 3 once we finish here. So we take our formula here, the x-coordinate of the midpoint equals the x-coordinates for the two endpoints, t and u, added together, divided by 2. We know that the x-coordinate for the midpoint is 2, got that from right here. We know the x-coordinate for t is 1, we got that from right here. We don't know the x-coordinate from u, and here's our divided by 2. Multiply both sides of the equation by 2. 2 times 2 is 4. And all this times 2 just gets rid of the divided by 2 down here. We end up with 4 equals 1 plus x sub u, or the x-coordinate for u. Subtract 1 from each side, and 3 equals the x-coordinate of u. Over here, the y-coordinate for m is equal to the y-coordinate for t plus the y-coordinate for u divided by 2. So if we take a look here, y-coordinate for m, we know that it's 4. So we plug that in down here. We know that the y-coordinate for t is 1. So we plug that in for here. The thing we don't know is the y-coordinate for u. Multiply both sides times 2 to get rid of this divided by 2. 4 times 2 is 8. And 8 equals 1 plus u, y sub u. We go down here, well, we're going to take away the 1 from each side, and we get 7 equals y sub u. So our x-coordinate is 3, our y-coordinate is 7. In either case, we're basically using the same formula as we did to find the midpoint coordinates, but we're kind of plugging in different numbers. So in this case, we already knew the x and y coordinates for the midpoint. We had to kind of fill that in one of the endpoints and solve for the other one. All right. Last up, distance formula. You'll remember in a previous video we talked about finding the distance between 2 points when they were either straight up and down vertically in the grid or perfectly horizontal in the grid. In that case, all we had to do is subtract one x-coordinate from the other or one y-coordinate from the other. But what do we do when they are diagonal in the grid? Well, we happen to have a formula for that. And by the way, talk about formulas, this formula right here is built up on a whole bunch of stuff, right? It took a long time to kind of develop this formula. It's been around for quite a while. It is something we could trace back and figure out exactly how mathematicians agree that it works. But for our purposes, we're just going to say it works. All right, the distance is equal to, all right, you take the two x coordinates for the 2 points, you subtract one from the other, doesn't matter what order, and you square it. You take the y coordinates, doesn't matter what order, you subtract one from the other, and you square it. Then you take those two things, add them together, and then you take the square root overall. So let's look at an example. From A to B, our x coordinates are -2 and 1. So over here, -2 minus 1 squared. And then our y coordinates are -2 and 2. So -2 minus 2 and squared. So -2 minus 1 is -3, and -2 minus 2 is -4. -3 squared is 9. Be careful about this. If you don't put the parentheses around this and just punch it into your calculator. You punch in -3 squared without the parentheses, you'll get -9, and that will be wrong. And the calculator will make there's a difference between multiplying two -3's together, two negatives make a positive, and telling the calculator to basically take 3, square it, and then take the negative. Just basic. One thing to keep in mind is every single time you square a number, you always get something positive. If you ever square a number and get something negative, you've done something wrong, you punched a button in the calculator wrong. You should always get a positive number. So -3 squared is 9. -4 squared, 16. Add them together, 9 and 16, you get 25. And last, the square root of 25 is 5. When we talk about square roots, it's like the opposite of squaring. So 5 squared, 5 times 5 is 25, and the square root of 25 just takes us back to 5 again. The square root of a number is whatever you would multiply by itself to get that number. In this case, well, it's a whole number. 5 times 5 is 25, so the square root of 25 is 5. In most cases, however, it's not going to end up being a whole number. It's going to end up being some sort of crazy decimal. Let's take a look at that. Here, we're looking at that crazy decimal example. We're going to look at BC, and this is actually from the previous graph. So in this case, our x coordinates were 1 and -3, and our y coordinates were 2 and -2. So 1 and 3, 2 and -2. So 1 minus 3 is -2 squared. 2 minus -2 is -4 squared. -2 squared is 4. Remember, everything squared is positive. -4 squared is 16. Everything squared is positive. 4 and 16 is 20. There's no whole number I would multiply by itself to get 20. Right? 4 times 4 is 16. 5 times 5 is 25. There's no whole number. In fact, there's no like simple decimal in the middle that'll work either. Here is your best perfect exact answer. Square root of 20. But sometimes you have to turn that into a decimal, and then you just use the button on your calculator to do it. If you're not sure what that is, I'll help you find it. But when you take the square root of that, it's 4.47, and this little wavy equal sign means about equal to. So if I take 4.47 and square it or multiply it by itself, I'm not going to get 20, because I actually had to round this off. If I hadn't rounded off, that'd be a different story. Right? This is an approximate answer. It's about what the square root of 20 is. It's a good enough answer that can be used in real life. And what I mean by that is 4.47, that's almost 4.5. I could actually measure something out that was 4.5 feet or 4.5 yards or 4.5 inches long. Square root of 20, without getting the decimal, I have no idea what the square root of 20 is. I'm totally lost, right? So while this is a best perfect exact answer, this one here is what we would need for use in real life. The reason why it's oftentimes better to leave your answer like this is because, well, 4.47, there were actually more decimal places. Maybe this is good enough for one person. So maybe a carpenter might round this off to 4.5, but maybe a machinist who deals with metals that don't shrink or grow as much as wood might want 2 or 3 more decimal places after this. If you say square root of 20 and give that number to both these people, they can kind of take it to themselves, put it in the calculator, and round it off where they decide is best. All right, and that is distance formula. We've talked about midpoint formula, and then we've talked about midpoints, and we've talked about bisectors. Remember, midpoint is the halfway point between the ends of a segment. A bisector is anything that cuts through the segment at its midpoint. We talked about the tick marks that are used to remind us that the two sides are the same, the two segment lengths are the same. We talked about finding the midpoint on a grid with the midpoint formula. We used a little algebra in order to figure out what the length was of each of these sides. And finally, we used a little distance formula to find out what the distance was between 2 points that are diagonal in the plane. I think you're ready to do some exercises, bookwork, etc. Solve a problem. Good luck.